Okay, so there was one problem I forgot to do. This is from 6.1. It says 400 people came to last year's winter play. The ticket price was $5. This year, the drama club is hoping to earn money enough to take a trip to Broadway play. They estimate that for each 50-cent increase in the price, 10 fewer people will attend their play. How much do the tickets cost in order to maximize the income from this year's play, and what would that maximum income be? Okay, this can be a really complicated problem unless we think of it simply. So let's think about this. How much money did they make last year? Well, last year the tickets were $5, and they had 400 people show up. Well, that would be $2,000, right? Okay. So this year, what do they want to do? They want to make some changes. So let's let the X represent the change. And what they're going to do is they're going to take that $5 price and they're going to raise it 50 cents or 0.5. And every time they raise it 0.5, so 0.5 times X, so X could be 1, it could be 2, it could be 3. They estimate that fewer people are going to show up. So instead of 400 people now, they're going to have 400 times 10x. So this makes sense here. We have the price of the ticket and the number of people. And they want to know how much do the tickets cost in order to maximize the income for this year. Well, let's take a look at what happens to this function if we multiply these two things together. We can make a little box. 400 minus 10x times 5 minus basically 1/2 x. 400 times 5 is 2,000. That's our y-intercept. That's what we started with last year. Minus 50x, and half of 400 is 200x. And then 10 times 1/2 is it's negative 10 times negative 1/2. I'm sorry, that's actually a positive 1/2. Negative 10 times positive 1/2 is negative 5, and then x times x is x squared. Okay, so that means we could rewrite this as negative 5x squared, 200x minus 50x, or 150x, plus the $2,000 that we made last year. Alright, now we have a function that represents our income, and we want to figure out what the highest point of this income is. Well, that's really just the vertex. And remember, in order to find the vertex, we first find the axis of symmetry. So we say x equals negative b over 2a. Well, in this situation, negative b is negative 150. 2 times a would be 2 times negative 5. You got negative 150 over negative 10, or x just equals 15. Okay, so the vertex is when x equals 15. And that means that the maximum is going to be when you plug this in. So what is I of 15 then? That's really what we want to know. What is I of 15 when x equals 15? So let's do that. Well, I got negative 5 times 15 squared plus 150 times 15 plus 2,000. And if you solve this all out, you should end up with 3125. You can mostly do it in your calculator. So that's how much money we can expect to make. That's the maximum amount of money we can expect to make. And that's one of the questions. They say, how much do the tickets cost in order to maximize the income from this year's play, and what would that maximum income be? So we did that first. Now we want to know what the tickets should cost. Well, that's easy. Look, we have an expression for ticket cost right here. We could say the ticket cost equals 5 plus 0.5x. Well, x is 15, so let's just do this real quick. Ticket equals 5 plus 0.5 of 15. 0.5 of 15 is 750, so 5 plus 750 is $12.50. All right, there we go. We've solved that problem.